Current division rule. Question: using current division rule, find VO. Here in this circuit, we have to find this VO by using current division rule. Solution: let's say this is current I1 and this is current I2. The current through 4 ohm and 2 ohm will be the same current because this 4 ohm and 2 ohm are connected in series. So first of all, we will find the value of I2 and then we will multiply this I2 with this 2 ohm and get the value of this VO. So by using current division rule, I2 is equal to this current, that is 11 ampere multiplied by opposite branch resistance. The opposite or parallel branch to this is 6 ohm. So it will be 6 divided by 6 plus this total resistance, that is 4 plus 2. 4 plus 2. So this will be the value of I2. Now we will solve this. So it will be 11 multiplied by 6 divided by 6 plus 4 plus 2. So it is 5.5 ampere. Now we have the value of this current, this I2. We can find the value of VO. VO is equal to, according to Ohm's law, V is equal to I into R. Here I is I2 and resistance value is 2 ohm. We have calculated the value of I2. I2 is 5.5 multiplied by 2. So this will be 5.5 multiplied by 2, it is 11. Since it is a voltage, so therefore VO is equal to 11 volt. So this is the answer for this question. Current division rule. Let's draw a circuit with a current source in parallel with two resistors. Let's say this is of 15 ohm and this is of 10 ohm, and this current source value is, let's say, 10 ampere. Let's say this current will be total current IT. This current, let's say this is current I1 and this is current I2. Now we have to find I1 and I2. Now according to current division rule, I1 is equal to total current, that is IT, multiplied by opposite branch resistance. That is, if we want to find current through this branch, then we have to take opposite branch resistance. Let's say this is resistance R1 and this is resistance R2. So its opposite or parallel branch resistance will be R2. So R2 divided by total resistance. So total resistance will be R1 plus R2. R1 plus R2. Now if we substitute all these values here, so this will be IT is 10 ampere multiplied by R2. R2 is 15 ohm divided by R1 plus R2. So R1 is 10 plus R2 is 15. Now if we solve this in calculator, So it will be 10 multiplied by 15 divided by 10 plus 15 is equal to 6. So this is the value of I1. Since it is current, so its unit will be ampere. Then next, we have to find the value of I2. So to find I2, let's write it here. I2 is equal to, the formula will be total current, that is IT multiplied by opposite branch resistance. Now this time we have to find this current. So its opposite or parallel branch is this branch. So opposite branch resistance will be R1. So this will be R1 divided by total resistance. So it will be R1 plus R2. R1 plus R2. If we substitute all the values, then the value of IT is 10 ampere multiplied by resistance R1 value is 10 ohm divided by R1. R1 is again 10 plus R2. R2 is 15 ohm. If we solve this in calculator, so it will be 10 multiplied by 10 divided by 10 plus 15. So it is 4 ampere. This is the value for I2. Now this is for when two resistors are connected in parallel. Now what if there are three resistors connected in parallel? That time, let's say this is a current source. This is one more resistor connected in parallel. Now if there is one more resistor connected in parallel, let's say this is 10 ampere, this is resistance R1, this is resistance R2, this is resistance R3. Let's say this is current I1, this is current I2, and this is current I3. And this current is total current IT, it is equal to 10 ampere. Now here, if we want to find, let's end this problem here. This is new question. So we have to find current I1. Before that, let's say this is of 10 ohm, this is of 15 ohm, and this is of 20 ohm. Now suppose we have to find the value of I1. So to find I1 by using current division rule, this will be total current IT multiplied by opposite or parallel branch resistance. So here we can see there are two resistances. So what we will do? We will solve this. So it will be 15 into 20, 15 into 20 divided by 15 plus 20 divided by total resistance. Now total resistance will be same, that is 10 plus this. So it will be 10 plus 15 into 20 divided by 15 plus 20. So if we solve this, the value of IT is 10 ampere. So if we solve this, 10 multiplied by 15 into 20 divided by 15 plus 20 divided by 10 plus 15 into 20 divided by 15 plus 20. So it will be 4.615. 4.615 ampere is the value of I1. Next we have to find the value of I2. This is the value of I1. Then next is I2. So to find I2, again total current IT multiplied by, now here opposite or parallel branch to this I2 is this R1 and this R3, this parallel resistance. So it will be R1 multiplied by R3 divided by R1 plus R3 divided by total. So it will be R2 plus this same value, that is R1 into R3 divided by R1 plus R3. So it will be here like this. Now if we substitute the value of IT, the value of IT is 10 ampere. So it will be 10 ampere multiplied by, now here R1 into R3. The value of R1 is 10 and here it is 20. So 10 into 20, 10 into 20 divided by 10 plus 20 divided by R2. The value of R2 is 15 ohm. So 15 plus same, that is 10 into 20 divided by 10 plus 20. If we solve this in calculator, so it will be 10 multiplied by 10 into 20 divided by 10 plus 20 divided by 15 plus 10 into 20 divided by 10 plus 20. So it is 3.07, 3.076. Since it is current, so its unit will be ampere. So this is the value of I2. Then next is I3. So to find I3 is equal to, again, total current, that is IT multiplied by parallel branch resistance. Now parallel branch to this I3 is R1 and R2. These two resistors are connected in parallel. So it will be R1 into R2 divided by R1 plus R2 divided by total, that is R3 plus this REQ. So R3 plus R1 plus R2 divided by R1. This is R1 into R2 divided by R1 plus R2. And this will be here. Now if we substitute all the values, the value of IT is 10 ampere multiplied by R1 into R2. So R1 into R2 will be 10 into 15. So 10 into 15, 10 multiplied by 15 divided by 10 plus 15 divided by R3. The value of R3 is 20. So 20 plus same, that is 10 into 15 divided by 10 plus 15. 10 plus 15. If we solve this, we get 10 into 10 multiplied by 15 divided by 10 plus 15 divided by 20 plus 10 into 15 divided by 10 plus 15. So it is 2.307. 2.307. Now since it is current, so its unit will be ampere. So this is the value of I3. Now if we want to verify our answer, so we have the value of I1, I2 and I3. So according to KCL, that is Kirchhoff's current law, IT, summation of all the currents entering a node is equal to summation of all the currents leaving the node. So here we can write according to KCL. KCL stands for Kirchhoff's current law. Summation of current in is equal to summation of current out. Now here entering current is IT. This is the entering current. So IT is equal to leaving current. Now leaving currents are I1 plus I2 plus I3. I1 plus I2 plus I3. Now IT is 10 ampere. Now we will verify I1. So I1 is 4.615 plus I2. I2 is 3.076 plus I3. I3 is 2.307. So if we solve this, we get 4.615 plus 3.076 plus 2.307. So it is 9.998, which is approximately same as 10 ampere. 9.998, which is same as 10 ampere. So therefore LHS, that is left hand side, is equal to RHS. So hence our answers are correct for I1, I2 and I3. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Current division. Question: what will be the reading of the ammeter in the given figure if voltmeter reads 12 volt? So here in this circuit, we have to find the value of this ammeter reading when this voltmeter reads 12 volt. That means the voltage across this 4 ohm is 12 volt. So from this 12 volt, we can find the current through this 4 ohm. The same current will flow through this 10 ohm, and here we will apply current division rule and we will find the value of this ammeter. Solution. So first of all, let's find this current. So this current I will be I is equal to V divided by R. The value of voltage is 12 volt. So this voltage is 12 volt. So it will be 12 divided by resistance value is 4 ohm. So the current will be 3 ampere. So this current is 3 ampere. Now we have to find this ammeter current. Let's say this current is current I1. So apply current division rule. Apply current division rule. So this will be I1 is equal to this current. Here we can see this current is I, that is 3 ampere, multiplied by opposite branch resistance. The opposite branch to this is 8 ohm. So it will be 8 ohm divided by same, that is 8 ohm plus. Now this same branch resistance, that is 3 plus 1. So it will be 3 plus 1. So therefore the value of current I1 is 3 multiplied by 8 divided by 8 plus 3 plus 1. 3 multiplied by 8 divided by 8 plus 3 plus 1. So it is 2 ampere. So the current through this ammeter will be 2 ampere. So here we can write ammeter current is equal to 2 ampere. So this is what we have to find in this question. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Current division. Question: a voltage source and two resistors are connected in parallel as in the given circuit. Suppose that Vs is equal to 150 volt, R1 is equal to 50 ohm and R2 is equal to 25 ohm. Find the currents I1 and I2 in each resistor. Here in this circuit, we have to find this I1 and this I2. The value of this voltage source Vs is given. Here we can see this R1 and R2 are connected in parallel. So the voltage across them will be same. So therefore, Vs is equal to V1 is equal to V2. So let's solve it. Solution. First of all, let's write Vs is equal to V1 is equal to V2. Here we can see the polarity of all the voltages are same. The value of Vs is 150 volt. So it will be 150 volt. Now here we can see this I1. So I1 is equal to current is equal to voltage divided by resistance. So here we can see voltage is V1 and resistance value is R1. So here we can see V1 is equal to 150 divided by the value of resistance R1. The value of resistance R1 is given, it is 50 ohm. So this will be 3 ampere. So therefore I1 is equal to 3 ampere. Now next we have to find the value of I2. So I2 is equal to, now here we can see this I2 direction is opposite to this V2. So this direction is negative. So here we can write minus, then voltage divided by resistance. So voltage is V2 divided by resistance is R2. So it will be V2 divided by R2. V2 divided by R2. So voltage V2 is, here we can see voltage V2 is 150. So this will be minus 150 divided by resistance R2. So resistance R2 is equal to 25 ohm. So this will be 25. So therefore I2 is equal to, this will be minus 6 ampere. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, don't forget to subscribe to this channel. Current division. Question: find the current in each branch of the given network if the total current is 2.55 ampere. So here in this circuit, the value of total current is given and the value of this voltage is given. The value of this resistance and this resistance is given. So first of all, we have to find the value of this resistance. So let's solve it. Solution. First of all, this current is given. So this current is 2.55 ampere. So here this will be 2.55 ampere. Now let's find the value of this resistance R. Now this will be, according to Ohm's law, I is equal to V by R. Now here the value of this I is 2.55 ampere. So this will be 2.55 is equal to, the value of voltage is given, it is 10 volt. Now we have to find the value of this total resistance R. So total resistance R will be R is equal to 10 divided by 2.55. So this will be 10 divided by 2.55. So it is 3.921, or we can write 200 by 51. So let's write 200 by 51 to get the exact answer. 200 divided by 51. Since it is resistance, so its unit will be ohm. So R is equal to 200 divided by 51 ohm. This is the total resistance. But here the resistance is connected in parallel form. So this will be resistance R is equal to, this will be 2 plus 8. 2 plus 8 will be 10 ohm. And this will be, so here we can write 2 plus 8 is equal to 10 ohm. And here this will be 5 plus R. So 5 plus R. These are the two resistances. Let's say this resistance is resistance R1 and this resistance is resistance R2. So here we can write R1 parallel with R2. So this will be R1 into R2 divided by R1 plus R2. So R1 value is 10 ohm. So 10 multiplied by R2. The value of R2 is 5 plus R. So 5 plus R divided by same 10 plus 5 plus R. So this will be 50. 50 plus 10 R divided by, this will be 15 plus R. Now the value of equivalent resistance is given. It is 200 by 51. So here we can write 200 divided by 51. So let's solve this and find the value of R. So if we take this on this side, so it will be 200 divided by 51 multiplied by 15 plus R is equal to 50 plus 10 R. Now if we simplify this, so it will be 200 divided by 51 multiplied by 15. So 200 divided by 51 multiplied by 15. So it is 58.82. So 58.82 plus, this will be 200 divided by 51. So it is 3.92. 3.92 R is equal to 50 plus 10 R. So if we take this R on this side and this 50 on this side, so it will be 58.82, then minus 50 is equal to 10 R minus 3.92 R. So this will be 8.82 is equal to, now this will be 10 minus 3.92, 10 minus 3.92. So it is 6.08, 6.08 R. So therefore R is equal to 8.82 divided by 6.08. So therefore R is equal to 8.82 divided by 6.08. 8.82 divided by 6.08. So it is 1.45. 1.45. Since it is resistance, so its unit will be ohm. Now we got the value of this resistance R. So we can easily find the value of I1 and I2. Since they are connected in parallel, so the voltage across them will be same. So we can easily find the value of I1. So I1 is equal to V divided by R1. So the value of voltage V is, it will be same, that is 10 volt. So 10 volt divided by resistance R1. So resistance R1 is 10 ohm. So therefore current I1 is equal to 10 by 10, that is 1 ampere. So therefore I1 is equal to 1 ampere. Now next I2. So I2 is equal to V divided by R2. So the value of voltage V is again 10 divided by resistance R2. So R2 is, here we can see R2 is equal to 5 plus R. R2 is equal to 5 plus R. So here we can write 5 plus R. And the value of this R is 5 plus this R is, here we can see we have just found the value of this R, and it is 1.45. It is 1.45. So therefore I2 is equal to 10 divided by 5 plus 1.45. It is 1.55. 1.55 ampere is the value of I2. So this is how we can find the currents. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, don't forget to share to this video. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, don't forget to subscribe to this channel. Current division. Question: the total current flowing through a parallel connection of 20 ohm and 60 ohm resistors is 40 ampere. What will be the current flowing through the 60 ohm resistor? Solution. So first of all, we have to make the circuit diagram. So let's say this is one resistor. Here in this question, the total current is given, it is 40 ampere. So this current is 40 ampere and two resistors are connected in parallel of 20 ohm and 60 ohm. So let's say this is 60 ohm and this is 20 ohm. Then next, what will be the current flowing through the 60 ohm resistor? Then we have to find this current. Let's say this current is current I1. So here we can use current division rule by using current division rule. By using current division rule, I1 is equal to this current, that is 40 ampere, multiplied by opposite branch resistance. The opposite branch resistance to this is 20 ohm. This is 20 ohm. So 20 divided by 20 plus this resistance 60. So if we solve this, we get I1 is equal to 40 multiplied by 20 divided by 20 plus 60. So it is 10 ampere. So therefore, the current flowing through the 60 ohm resistor is 10 ampere. So this is how we can find current by using current division rule. Don't forget to share to this video. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, don't forget to subscribe to this channel. Current division. Question: for the network shown in figure, the value of supply current and source EMF is. Here in this circuit, we have to find this supply current and this EMF source value. Here in this circuit, the value of resistance is given and also the value of this current I4 is given. So from this given data, we have to find supply current and source EMF. Solution. So let's solve this circuit. So first of all, here we can see these two resistances are connected in series. So their equivalent will be 8 plus 6. So this will be 14 ohm. Now here we can see this current is 3 ampere. So by using current division rule, we can say total current, or we can say current I4 is equal to this current I multiplied by opposite branch resistance. So opposite branch resistance is 16 ohm divided by 16 plus 8. Now here the value of this I4 is known, it is 3 ampere. So this will be 3 is equal to I multiplied by 16 divided by, this will be 24. Now we can easily find the value of total current I. So I is equal to, if we take this on this side, so it will be 3 multiplied by 24 divided by 16. So therefore I is equal to 3 multiplied by 24 divided by 16. So it is 4.5 ampere. So 4.5 ampere is the value of current, total current I. Also here we can see this resistance is 14 ohm. So we can find the voltage across this will be, let's say this will be V1 plus V2. So V1 plus V2 is equal to, the resistance value is 14 ohm multiplied by current value. So current will be total current, and it is 4.5. 4.5. So this will be 14 multiplied by 4.5. So it is 63 volt. So this voltage is 63 volt. Now we have to find this voltage, that is V3. V3 will be current. The voltage across this R3 and this R4 will be same because they are connected in parallel. So this V3 is equal to this R4, that is 8 ohm multiplied by current value, that is 3 ampere. So this will be 24 volt. So the total voltage will be V1 plus V2 plus V3. So here we can write total voltage is equal to V1 plus V2 plus V3. V1 plus V2 is 63 plus V3, it is 24. So if we solve this, so this will be 7, and here this will be 8, 87. So total voltage is, or EMF is, or source voltage is 87 volt. So this is how we can find total current and source EMF. Don't forget to share to this video. Thanks for watching. Check out the affiliate links in the description below. Also feel free to install the app. Current division. Question: find the current flowing through the 6 ohm resistor in the above figure. So here in this circuit, we have to find the current through this 6 ohm resistance. So here we can apply current division rule. So let's solve this. So by using current division rule, by using current division rule, we have to find this current I. So I is equal to this current. So it will be 12 multiplied by opposite branch resistance. Now here the opposite branch to this is this 4 ohm parallel with 12 ohm. So 4 ohm parallel with 12 ohm. So this will be 4 into 12 divided by 4 plus 12. So this will be 4 into 12 divided by 4 plus 12. So it is 3 ohm. So this equivalent resistance will be 3 ohm divided by 3 plus 6. So if we solve this, it will be 12 multiplied by 3 divided by 3 plus 6. So it is 4 ampere. So the current through this 6 ohm will be 4 ampere. So this is how we can find current by using current division rule. Thanks for watching. Also, don't forget to subscribe to this channel. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, don't forget to subscribe to this channel. Current division question. In a circuit, two 9 ohms resistances are connected in series to a parallel combination of two 2 ohms resistances. If the supply voltage is 30 volt, 38 volt, the value of current in the circuit will be. So first of all, two 9 ohms resistances are connected in series. So let's draw the circuit. So this is 9 ohm resistance and this is also 9 ohm resistance. So this is 9 ohm. 9 ohm are connected in series and they are connected in series with parallel combination of two 2 ohm. So this will be of 2 ohm. Also this will be of 2 ohm. The supply voltage given to this circuit is it is 38 volt. So this voltage source value will be 38 volt. 38 volt. We have to find this supply current. So first of all, according to Ohm's law, current is equal to voltage divided by resistance. The value of voltage is 38 and the value of resistance will be 9 plus 9. So 9 plus 9 plus, now this 2 ohm and this 2 ohm are connected in parallel. So it will be 2 divided by 2. So it is equal to 38 divided by 9 plus 9 plus this will be 1. So it is 2 ampere. So the total current is I is equal to 2 ampere. So this is how we can find current. Thanks for watching. To get the free notes of electrical circuits, check the link in the comment section and install the app for free. Also, don't forget to subscribe to this channel. Current division question. Determine the voltage drop across the 8 ohm resistor of the circuit shown in figure. So here in this circuit, we have to find the voltage drop across this 8 ohm resistor by using current division rule. So let's solve this circuit. Solution. So first of all, to find the voltage drop across this 4 ohm, we have to find this current. Let's say this current is current I1. So by using current division rule, the I1 is equal to this current, that is 5 ampere multiplied by opposite branch resistance. So opposite branch resistance will be 4 ohm plus 4 ohm. So it will be 8 ohm. So 8 ohm divided by 8 ohm plus this will be 8 plus 4. So this will be 12 ohm. So if we solve this, we get I1 is equal to 5 multiplied by 8 divided by 8 plus 12. So it is 2 ampere. So this current is 2 ampere. So the voltage drop across this 8 ohm will be, it will be V8 ohm is equal to I1 into 8. So I1 value is 2 multiplied by 8. So this will be 16 ohm, 16 volt. So the value of V8 ohm is equal to 16 volt. So this is how we can find voltage drop across resistor by using current division rule. Thanks for watching.